Alright, this is the DT paper of 2019, paper 2, A-level product design. And this is question 1. Figure 1 and 2 show two power drills. The first one is a die-cast aluminium drill which requires main electricity, and the chuck key is the key required to open the drill housing so that the drill bit can go in, and then you can fasten it with the chuck key. And keyless means you don't need the key, you can just do it with your hand on the end. Flathead screws is used to join the entire drill together. This uses fasteners. And the labels show the center of mass of the drill. So the center of mass is over here, so it's the most heaviest over here. And 2 shows that it's over there. What's the question? Compare the two drills shown. In your answer, you should refer to ergonomic factors and design safety. Okay. Well, already I can see that there are more points about ergonomic factors than safety, but you can talk about anything. I would prefer to do 8 marks to 4 marks. That's what I would write. So, for my first point, the most easiest about ergonomic is grip. Now I can see that the grip over here, this part, is shaped like a hand. This part over here, it's easy to hold, whereas this part, it's very thick, it's very bulky, it's not very easy to hold. So I would say figure 2 has a ergonomic grip. Now you have to explain because you can't use the word ergonomic grip. Ergonomic grip. In the shape of a hand. Shape of a hand for a tight grip. Tight, or you can say comfortable grip. Whereas figure 1, because it's a compare question, you have to talk about both at once to get the both marks per point. Figure 1 has a very thick handle to hold, and since it's injection molded, we can say that it does not have any grip, because assuming figure 2 will have a grip since it's injection molded, so figure 1 won't have a grip. Two very thick handle with no grips to hold it comfortably. That could be your first 2 marks. Our second point, we can talk about the wire. Of course, the second one doesn't require a wire, and the first one requires a wire. So that's a very big point we can talk about. We can say, since we talked good about figure 2 and then bad about figure 1, we can now talk about an advantage of figure 1 now. Oh, sorry. Figure 1, we can say, requires a wire to operate, which actually limits it. Sorry, it's not an advantage, it's a disadvantage, which limits its usability where there is no electricity, basically, where there is no, because like many houses, when they start electricity, because when you're building a house, you won't obviously have power as soon as you start building it, so a cordless drill would be better for the start. But should the question ever ask why figure 1 is better, since it's mains powered 230 volts, it's going to have a much stronger motor, and it's going to be able to drill much faster and with much more torque, basically much more strength. Figure 2 won't be as strong. Over here we can talk about how figure 2 does not require a direct connection, which makes it very portable to use. You can also have multiple batteries with you, should it run out of charge. The third part I would write is the chuck. Simple. I'm just going by the points. So 1, 2, 3. I'm just going in order. So chuck is the next thing we can tie. Figure 2 requires no chuck. To insert the drill bit, now this no chuck means no no oh, sorry, not no chuck, no key for the chuck, which removes um, extra tools, because otherwise you would require the key with you. And you can reverse the point for figure 1, as it's a compare question. Requires a key, therefore extra tooling would be required. And now you talk about a negative. Extra tooling would be required, making it harder to operate. Harder to operate. Let's see. That's 6 marks, I would say. 2 marks, 2 marks, 2 marks. Let's say our 8th mark. 8 marks. Um, we can talk about casting joined by flathead screws and security fasteners as my next point, but I would prefer that to be put into safety. So let's talk about center of mass. Um, figure 2 has its center of mass concentrated in the middle. Now this is good because this will make it so that the strain does not make it lean towards the forward, because if it was in the middle it's gonna make it go like that. That's not very good. Over here it's nice and balanced in the center, and it's gonna take the force in the middle, which reduces stress when used by the customer. Now you can reverse this and say figure 1 has its center of mass in the front, making it tough to handle as it leans forward. All right, I think that's 8 marks. Good enough. Should you require more points? I think what we can say. I can actually see a torque setting over here, like directly over here on the black part, which reverses the drill side. And it's much easier to click the button over here than to switch it on the top, as I can see it over here. So that could be another point, that it's easier to change direction while in use. So yeah. And overall, ABS is lighter than figure 1. So if it's lighter, it's obviously easier to use, whereas figure 1 would be much heavier and harder to control, as we said, by the grip. Design safety. What we can say for design safety is that, okay, this is a very big concern. It says it's created out of aluminium. Now, of course, if now for safety, figure 1 is made out of aluminium. Now, of course, if it's made out of aluminium, it's a conductor. Therefore, if a wire uh, goes loose in the system, it is a major electrical hazard to use, of course, because if it's a conductor and the wires are loose, it's gonna shock you, seriously harming you. Figure 2, on the other hand, is an insulator. It's plastic. It's ABS insulator, and also it's low voltage. 12 volts will probably not even be felt by a human, and I believe it's 8.8 volts, 9.6, sorry. Okay, we can also see, I was just looking at it, figure 2 actually can stand on its own, whereas figure 1 is kept on a table, as you can see. So it's easier, no, sorry, figure 2, easier to grip, easier to pick up rather, after use. Um, as it has a stand. So it's easier to pick up after use, and you don't accidentally drop it on your finger or anything, because figure 1, if it drops on your finger or toes or anything like that, that would hurt a lot. Under a few quick points we can say is security fasteners, uh, restrict unauthorized access, restrict access to the average user, because if it was a flathead screw, it could easily be opened by anyone with a screwdriver, to be fair. So it's much easier if it's a security fastener that not everyone can open. We can also say, this is just another point, even we've got all our 12 marks, but what we can also say is that this is a thermal conductor, so after use it's going to get really hot, and it will be really hard to use it, so you're actually going to have to put it down, let it cool down, and then use it, whereas 2 is just straight up plastic, it's an insulator, all the heat will come out of the dedicated holes. So that's question 1 done. Alright, oh, sorry. Question 2. Evaluate the impact of the Waste Electrical and Electronic Equipment Directive on manufacturers of portable electrical hand tools. Now, WEEE, which is the Waste Electrical and Electronic Equipment Directive, um, has to be done by their manufacturers, and they have to make sure that this directive is met. Now, the impact, what actually happens, is manufacturers have to provide information on how to safely dispose of the electrical equipment or electronic equipment, and safely and the correct way to do so. So this allows the user to not like be injured while they're disposing it, and it's actually like reused. So the manufacturers have to provide information. So it's only on, sorry, I didn't read this, directive on manufacturers. So this is only how manufacturers are affected. Okay, manufacturers have to provide the correct specific symbol for the E and E product, which means electronic and electrical equipment. So that's another thing the manufacturers have to do. Manufacturers will also have to, like, like the buyback for Apple products and stuff like that. Manufacturers have to organize a take back scheme where they take the technology back. Oh, sorry, not technology, take back scheme. Technology back after they're done using it for disposal or reuse. Of course, this can be direct or indirect by the manufacturer. So that means they just have to do it in some way or other. Manufacturers have to register themselves nationally so that they know who has the WEEE directive and is registered with the directive nationally with the WEEE register, registrar in the UK. Manufacturers also have to declare the materials they're using and like putting on shelves. Alright, question 3 is explain 4 ways cordless power tools can be designed to be disassembled. Cordless power tools can be designed to disassemble. Okay, so they're wireless and stuff like that. Okay, cordless power tools, usually they have a detachable battery and keyless chucks as we saw in the first question. So a very easy way we can say is modular design. They can incorporate a modular design. Um, this means, so since it's 4 times 2 marks, we have to give a point and then its explanation basically, or how it's easy to, like your point and then how it makes it easy to disassemble. So modular design is my point, and the way it can easily be disassembled is that um, the so modular design, they can be easily removed and they can be used somewhere else on different products since they have standard fittings. Another big thing is remove adhesives and then used standard fittings. Using like standard fittings or mechanical fittings would be a better way. This will help disassembly by reducing adhesive contamination. And honestly, overall reduces overall parts, reduces overall parts. Um, okay. All different plastics, different polymers can have their SPI codes, which informs what product, no, how the polymer is recycled. Okay. Um, disassembly instructions can be given. So now disassembly instructions can be provided to aid the disassembly by the user themselves, so they don't have to go to another company or anything like that and have them disassemble the product for them. They can just directly disassemble it and recycle it themselves, which reduces the work for the company and overall helps the product be recycled in the end as well, which makes it easy to disassemble. Right, question 4. The battery life of a rechargeable battery was tested in a handheld electronic device. The test was repeated 11 times with a new battery each time. The results are shown. Now, of course, since it's asking us to draw a box plot, the first thing we would have to do is order all the values in our the values we're given. So I've already ordered them out over here. And the first thing we have to do, the easiest thing would be the lower and the upper quartile. So let's just do that. 65. That would be about here. Yep, that's 65. Highest is 220. That would be about there. Let me do that again. 220. Oh, 220. The median would be 130 since it's the middle value between them. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. That's the median value. That's 130. The lower quartile comes in between that and 130, so that would be between these two values. And when it's between, we take the upper value, so that's 90. And the upper value between, so it's 190 over here. And yeah, that's also 90. 2 and 2, and then that's lower quartile, that's 190, so that's 190. And 90. Then we join the box plot, which is one line over here, over here. That's our box plot, done. With the values of 65, 90, 130, 190. Don't write this, I was just showing you for the values, and 220. That's question 4 done. 4 marks is, there we go. The 4 marks as described is the median, the lower, the upper quartile, and the range is for the full marks. Alright, question 5. When producing a die-cutting package, 3 different independently occurring faults are possible with these probabilities. A and B are minor faults which must be monitored and will only fail quality if both faults are seen on a single product. So it only rejects if A and B are both faulty. C is a critical fault and any product suffering from this fault will fail it. So if it's C, you immediately fail it. If a batch of 10,000 packages are produced, calculate how many products will be expected to fail quality control. Alright, so let's first calculate A and B. So that's 1 over 100 times 1 over 100. And if we do that on a calculator, 1 second. 1 over 100 times 1 over 100. That gives us a value of 1 over 10,000. So that's the chance it will fail if A and B happens. This is also plus 1 over 500. Now if we use 1 over 500, we want to normalize that to 10,000. So 1 over 500, we will multiply this by 10,000 divided by 500. That's 20. So 20 over 10,000. So this is for C. So we would simply do 1 over 10,000 plus 20 over 10,000, which will give us 21,000. So this is for A and B. This is for A and B or C. So all of it. 21 over 10,000. And a batch of 10,000 packages are produced. Calculate how many products will be. Well, since this is 21 out of every 10,000 things, we already know it's 21 products that will fail quality check. Okay, question 6. State 4 ways a manufacturer may use quality assurance procedures and policies to reduce the rate of errors during die cutting of packaging nets. Okay, so quality assurance. The easiest way of quality assurance is regular visual inspections. Just looking at the product, making sure it's fine, it looks fine, is an assurance. Now, of course, if you're having visual inspections, you need someone to do it, and for that you'll need regular staff training as well to make sure they are checking properly. Another thing we can do, since it's die cutting and dies can go blunt, you want to make sure that the blade is regularly changed. Regu to avoid a blunt blade. Because, does it say why? No, okay. Should you need to know why, you can say it's because blunt blades don't cut cleanly. Neatly. Oh, okay. Since it says policies, we can also, from policies, we can deduce ISO, which is the International Standards Organization, and the ISO for materials is ISO 9001. So we can say, um, accept supplies um, from companies that are ISO 9001 certified. Another point, should we want to remember it, is for the fifth point, we could say that um, tolerances must be set on the material. Let's say thickness, for example. It doesn't matter what. One factor must be, of course. Could be thickness, could be size, could be anything. Okay, question 7 shows a submarine which asks us to explain the specific virtual modeling techniques that may be used to test the design of a submarine before its production. Never seen a commercial production of a submarine, but the first thing I see about a submarine is it's gonna go in water. So our first point instantly can be CFD, which is computational fluid dynamics. This is a software that is used to simulate pressures and the flow of liquids um, around the submarine, of course. This means you can test in deep water simulations without producing it, or without a prototype. You can just test it out. Without a physical prototype, rather, you'll need something digital. That's 2 marks. Another thing we can say, another thing I can see are these portholes. You want to make sure how much the researcher or the person inside the submarine can see through the portholes. So you can use virtual reality models to check through the portholes or windows and see the visibility range or the visibility angles, which means how much can the person inside actually see, because they're not going to be able to see anything on this side because there's no windows over there. They'll be able to see from the front, but yeah, there is a very small hatch over there, but that doesn't allow much visibility, so that can be tested. Um, of course, all submarines have hydraulics and pneumatics. pneumatic systems. Oh, okay. I just remembered a point. Um, the electronics in the system. So the electronics and their systems or diagrams or whatever you want to call it can be simulated, can be designed or simulated prior to production to ensure it works. Oh, sorry. Ensure the system works. This is a bit advanced, you don't need to know this, but you can use this with Autodesk Eagle. Autodesk Eagle designs circuits. You don't need to know this, but of course. This is a valid point. Another point you could say is materials can be tested along with their weight, their distribution, density, all other things that can be tested. Question 8 talks about total quality management and describing what total quality management is. Now, total quality management is everything, which allows us to remember that it is at all levels, and quality management is when a company tries to improve continually. So, TQM is referring to continuous improvement within a company. That's your first mark, I believe. All levels of management, including all individuals. For a specific application, give 2 reasons why a go, no go gauge would be used. Okay. A go, no go gauge is like a small check that basically sees if an item fits within its tolerance range. If it does not, it is a no-go, and if it fits, it's a go. So you don't change it, it's just a gauge that once made, it requires almost zero calibration. So go, no go gauge requires minimal calibration, or like rarely requires, and it also really requires minimal calibration, and really requires calibration. Um, oh, specific application, I did not see this. Specific application, we can say for this point, I'll just say a component width. I said it, but I removed the drawing component width. So we'll just check if the component width fits within the go no go gauge. So you don't need to calibrate it, you just check it and you're good. You check the next item, you're good. The next thing we can say, it is much faster. Then let's say vernier calipers, because you You need to calibrate them, you need to set the size, and you need to read it. It takes a lot of time. State 3 characteristics associated with the products from the Memphis Postmodern Design Group. Okay, the most common one was use of very bold, or not very, just bold color schemes. They used unconventional materials. They used patterns on many surface designs. And a fourth one, should you want to remember it, um, they use simplistic rather, geometric forms. They use simplistic geometric forms to create complex alternating positions, or like juxtapositions or alternations. Describe the methods used by manufacturer to conserve energy and materials during product development and manufacture. This is a very easy question. Um, I'll write down a lot of points for this one, and you can pick whichever one you want to remember. So we can use CAD. CAD can be used, actually I'll make it simple points. Used for tessellation on materials. So what this point refers to is that tessellation on materials can be used um, before cutting on CNC machines, so that the machine knows the best way to cut the most materials out of that same sheet or like board. So let's say you have a board of MDF and you used tessellation on it, and now you're able to cut 20 pieces out of it instead of just 17 or 18. So you reduce material waste. Material waste. Okay, that's one point. Another point we can say is use more CNC machines. Why, you may ask? Because they are accurate, and if they're accurate, of course, there's just less waste. Another point we can say is automated lighting. This reduces energy waste, of course. Electrical or energy consumption. Fourth point we can say is using renewable sources of energy. This could mean that they put some solar panels on the roof of their factory, or just put some windmills and anything like that that would reduce the consumption of energy or fossil fuels. Um, they can use recycled materials, recycled usage. This obviously reduces the waste of new materials being used, so less new materials used. Another point we can say is um, using reusable molds. Reusable molds, which would reduce the need produce new molds repeatedly. Another point we can say is because it also said rapid, you could say during product development. Um, for this, we could say designers can design the product so the designers can design the product with less volume or material thickness, which would ultimately reduce the amount of material you used. If it's thinner, of course, you're using less by default. Rapid prototyping. It's an efficient manner and this also, rapid prototyping, also allows us to produce testable prototypes to make sure it actually works. Before you put it into full-scale production and then it doesn't work, that's a lot of waste, a lot of loss. Oh yeah, not only you can use automated lightings, you can also use low energy lightings or energy efficient lightings. This could be in the form of LED lights. They're very, very energy. Machines can go into standby mode when they're not in use. This would of course reduce energy usage. I think if we filled up the entire space, I think that's enough points. Figure 4 shows a low carbon steel component with a volume of 11,100 millimeters cubed. The density of low carbon steel is 7.85 grams per centimeter cubed. The component is to be hot dipped galvanized. The galvanizing process increases the mass of the component by 5%. Okay, so this tells us we just have to put a 1.05 multiplier in the end. That's all we have to do, and calculate the mass of the component in grams. Okay. So the first thing we'll have to do is either we convert this to to centimeters or convert this to millimeters. I think I'll convert I will convert the density into millimeters. So we divide that by 1,000. So I'll do it here. 7.85 g per cm cubed turns into 0.007885 g per millimeter cubed. If you were to do this, this would be 11.1 centimeters cubed. So I'll do it both ways. Actually, it'll be easier then. So that's for millimeters and that's for centimeters of volume. This would be now 11100 multiplied by 0.00785. This would give us the actual mass, and that would equal to 110 times 0.00785 gives us 87.135 grams. Now, of course, if we were to do it this way, it would be 11.1 times 7.85, which would also still, if we multiplied these both together, it would still be 87.135 grams. Now, we're using that 87.135 5g. We can now multiply this by 1.05, as I said, the multiplier, because it increases the mass by 5%. And if I do that, 1.05 gives us 91.5 grams. I would of course leave it to 3 significant figures because they have given us 3 significant figures over here and 3 significant figures over here, so I would say the best bet would be to leave it at 3 significant figures. Okay, this is question 13. Compare the two radios shown in figure 5 and figure 6. In your answer, you should refer to the development in microelectronics, so the electronics used in the product, as well as its materials. It's a 12 marker. And I think we can split it 6 marks to 6 marks, or we could do 8 marks to microelectronics and 4 marks to materials. I'll give 6, 6 each, and since we already know the structure of compare questions, I will simply give out the points that I would use. Now let's see, the first thing I can say very easily is that figure 5 uses analog switches. We can see that by these analog knobs over here, as well as the analog finder or radio finder, like the station finder. Figure 6, on the other hand, uses digital electronics, as you can see by the menu screen. Now, why is this good? Because this allows users to search stations, like radio stations, and even it can have saved radio stations. What else can we say for microelectronics? Figure 6 has a digital screen. We don't have to say why it's bad or not because it says compare. It does not say compare and evaluate, compare and analyze. It just says compare. So we just have to say what's different and what might be same. Like their function is same, but then again, it's telling us to talk microelectronics or materials. So we have to be specific on that. Has a digital screen. This digital screen might make controlling it easier. Also, it has a remote. That's another point on itself. Figure 6 has a remote. So it can be used by a distance. Could be sitting down, relaxing, and then change your radio station. Okay, we can see that the electronics used in figure 5 is a thermonic valve and integrated circuit. Now I don't know what a thermionic valve is, but since it's from 1950s, I can surely say that it is less reliable. 5 uses thermionic valves, which is less reliable than ICs, integrated circuits. Just making it quick. Okay, we can say figure 6. Since it uses ICs, they are more energy efficient. Because we talked about thermionic valves, now we want to talk about ICs, are more energy efficient. And the use of transistors in ICs prevents overheating because they're very lightweight. There can be more points to say. I'm not going to write them down because I think they're enough, but I'll say them out loud. Um, we can say figure 6, since it has a remote, you require much less movement, so it's much easier to press the button. Should someone have a disability, it would be much easier to click the buttons on this. Less force is required. Figure 5 requires these mechanical switches to be used, and they're delicate as they're thermionic valves. Of course, since it's 1950s, it's not going to be very tough. Um, Figure 6 is more energy efficient. We said that. It's got a screen and basically anything else you can spot. We can also see that it has better speakers, so we can say that it would be perhaps much louder or um, along those lines. Okay, now we can talk about development in materials. Sorry. Now we can see that this is created by fabricated plywood and injection molded thermoplastic. Okay, now plywood for the first one, or rather I should say figure 5, would be designed as a furniture because it looks like a piece of furniture rather than a piece of electrical equipment. So plywood usage would be referring to the station or the radio being a furniture, as that's what they believed in the 1950s, and therefore not portable. Now, since it's also created from fabricated plywood, it requires many components. We're still talking about figure 5, many components used. Now, of course, since there are many components used, it would have a high complexity during assembly. 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 Okay, what else can we say? Injection molded thermoplastic. We have to say something about that. Okay, so injection molded thermoplastic. For injection molded techniques, we can say that it's gonna have internal, um, what do you call it? Internal supports so that the product holds itself up, and therefore reducing material usage. Figure 6, as it is using IMTs, or injection molded thermoplastic, it can have a range of complex forms, perhaps colors, because you can add pigments and it just changes colors quite easily, finishes, whatever you want to call it. It can have a lot more of that. Okay, that's like 6 marks already, but we'll write a few more points. Okay, injection molded thermoplastics can be mass produced much faster than wooden products, of course. Therefore, many more can be made in a significantly short amount of time. Shorter amount of time, significantly less time. Yeah, I think that's everything that needs to be said. I'm just trying to think of anything else I could say. We could talk about that being these knobs being standardized equipments, because I've seen these knobs being used in old boilers. So it could be that these are standardized switches. Okay. 3 reasons why a designer may use a focus group. A focus group is a small set of people that look at your product and say what's good about it and what's bad about it. So first thing is to gain feedback on concepts, on design concepts rather, on models handling the product. Observe the user handling the product. This shows how the user uses the product. Perhaps deciding the price point of said product. Design. Now, more points can be said. You can get a range of views from a focus points, which is not possible from one single person. This can also, um, from feedback, you can also say, like, you can break it down if you don't have any ideas in the actual thing. You can say that you can gather suggestions for improvement or constructive criticism from the production of before you produce the design. So there are many things, anything that would help to make your product better. Figure 7 shows a label often found on electronic products. Explain the meaning of the label in Figure 7. Okay, this is very easy. This is what is known as a eco label. So that's one mark probably. For energy consumption, it gives you various data such as it's A-star rated. Because you have to keep in mind it is talking about the label shown in Figure 7, so it means everything on this rated at thing. And it also the label shows product specific information. What type of things we can see? Well, from this I can see that it is perhaps a dishwasher because it's got a symbol of dishes, it's got a symbol of loudness. So assuming this is a dishwasher, this is the water usage per year. Not sure what the ABCDEFG is, but this is how many sets of plates it can take. This is the sound it creates at 44 decibels when it's in operation. And this is the amount of energy it uses, so 220 kilowatts per annum. So if it was, yeah, standby, I believe. And that is the energy efficiency rating. And that's the entire paper.